Welcome to the Explainer. Today, we are unlocking the superpowers hidden inside one of the most fundamental tools in JavaScript, the array. We're going to see how you can stop doing all the heavy lifting and instead make your data do the work for you. Really think about that for a second. What if, instead of writing these manual loops to go through your lists of data, you could just, tell your array what you want and it just hands you the answer? Well, that's not some far-off dream. It's exactly what modern array methods let you do. So let's meet our hero for this little data journey. It's a super simple array of numbers, just 1 through 5. We're going to take this basic list and put it through its paces to see what it's really capable of. Okay, our first stop is all about shaping our data. First, we're going to learn how to transform every single item in our array, and then we'll see how to filter it down so we're only left with the stuff we actually care about. First up, we've got map. The best way to think about map is like a factory assembly line. Each item from our original array gets put on the belt, a function does something to it, paints it a new color, changes its shape, and then a new, transformed item comes out the other end into a completely new array. Let's see it in action. It's so cool. We call .map right on our numbers array, and we give it a really simple instruction. For every number, which we'll call n, just return n times 2. That's it. It's so clean and easy to read. And boom, the result is a brand new array where every value has been doubled. But here's the really important part. Our original numbers array is completely untouched. It's still 1, 2, 3, 4, 5. And this is a core principle here. We try to avoid changing or mutating our original data. It's so much safer. All right, next up is filter. Now, if map is an assembly line, filter is like a bouncer at a club with a very strict guest list. It looks at every single item in the array, checks it against your condition, and only lets the ones that pass the test into the new exclusive array. So here, we're telling our array, hey, you go find all the even numbers for me. The test we give it is simple. Does the number, when you divide it by 2, have a remainder of 0? If the answer is yes, it's on the list. And just like that, from our original list of 5 numbers, we have this new, super focused array that just has the 2 even numbers. We didn't have to write a clunky for loop or a big if statement. We just described what we wanted and the array did the rest. That's power. So we can transform our data and we can filter it. That's awesome. Now let's see how we can start asking our data questions. Find a specific piece of information or just check what's inside. So find is like your personal search party. It works a lot like filter. It takes a test, it looks for things that match. But here's the key difference. The moment it gets a match, it stops searching and just returns that very first item. It's perfect when you know you only need one result and you need it fast. Sometimes you don't need the data itself. You just need a simple yes or no answer. And that is exactly where sum and every shine. Sum asks the question, hey, does at least one of the items in here pass my test? While every asks, do all of them pass the test? It's kind of like the difference between asking a crowd, is anyone here a doctor, versus is everyone here a doctor? Very different questions, very different answers. All right, for our final set of core actions, we're going to get to the bottom line. We're going to learn how to boil an entire array, no matter how big, down to just a single value. And, of course, how to get it all sorted in a specific order. And that brings us to reduce. Honestly, this might just be the most powerful array method of them all. It can take a whole list of values and, just like the name says, reduce it down to a single result. Its magic is this thing called an accumulator, which is just a value that it keeps and updates as it goes through the entire array. So, to get the sum of all our numbers, we use reduce. Let's break this down. X, that's our accumulator, our running total. N is just the current number it's looking at. For each item, we tell it, just add the current number to the running total. And that little 0 at the end, that is absolutely crucial. That's our starting value for the accumulator. And what's the final result? 15. The reduce method just crunched through the whole array for us. 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, plus 5 is 15, and it handed us back that one single summary value. So powerful. Okay, pro tip time. A really important warning about sorting. JavaScript's built-in .sort method
It actually changes the original array. That can be super dangerous. So to be safe, we first make a copy. The easiest way is with this .number syntax called the spread operator. Then we call sort on the copy and give it a little function to tell it how to order things. In this case, we're sorting from largest to smallest.
This is where it all comes together. This is the moment. We've learned about all these individual methods, right? But their true power, their real magic, is unleashed when we chain them together. We can create this beautiful, elegant pipeline for our data to just flow right through. Just look at this. It's the entire data journey in one single readable statement. It's amazing. First, we filter our original numbers for anything greater than 2. That gives us a new array, 3, 4, 5. Then that array flows directly into map, which takes each of those numbers and triples them, creating 9, 12, 15. And finally, that result gets piped right into reduce to add them all up, giving us the final answer, 36. It reads just like a story. So to round things out, let's just equip you with a few more essential gadgets for your array utility belt. These are the quick, everyday helpers that you're going to find yourself reaching for all the time. That spread operator, those 3 little dots, it is your absolute best friend. It's a multi-tool. As we just saw, it's perfect for making a quick, safe copy of an array. But you can also use it to effortlessly combine 2 or more arrays into one giant array, or even to spread out the elements of an array as individual arguments to a function. Super versatile. Okay, here's a classic one that trips up everybody, so listen close. Slice versus splice. The easy way to remember is that slice is the safe one. It just takes a slice of the pie and gives you a new copy, leaving the original pie alone. Splice, on the other hand, is destructive. It goes in and permanently removes or adds things to the original array. So you have to be really, really careful with that one. And now it's over to you. The best way, the only way to really get good at this stuff is to use it. So think of this as your first mission. Go find an array of data, any data, and see if you can filter it, transform it, and summarize it using these incredibly powerful methods. Just play around. So we've seen how to work with the data inside an array, but what's next? Well, in our next explainer, we're going to explore destructuring and modules. These are just incredible features for pulling data out of arrays and objects with total ease, and for organizing your code into clean, reusable chunks. It is a total game changer, and you are not going to want to miss it.